We're always talking about how accurate an AI is, but what about its confidence? What happens when there's this huge gap between how sure an AI says it is and how right it actually is? That right there is the core of whether we can actually trust these things. So let's start with a question you've probably thought about yourself. Okay, so let's really frame this. An AI, maybe it's looking at a medical scan or predicting the stock market, it tells you it's 99% confident. And that sounds amazing, right? A total slam dunk. But the real question, the one that really matters is, can you take that number at face value? Think of it like this. Imagine your local weather forecaster. Every single day they get on screen and say, I'm 99% certain it's going to be sunny tomorrow. But you've been keeping track and you realize they're only right about 70% of the time. You wouldn't just be annoyed, you'd stop trusting them completely. That's the problem of overconfidence, and it's a huge issue for a lot of today's most powerful AI models. All right, so how do we fix this mess? How do we get that forecaster's confidence to actually line up with their track record? Well, the answer is a concept called model calibration. It's all about one thing, aligning a model's confidence with reality. The idea behind this is actually super simple. Calibration is just checking how well a model's predicted probability, that percentage it gives you, matches what actually happens in the real world. So if a perfectly calibrated model says there's an 80% chance of rain, then out of all the times it said that, it really would rain 8 out of 10 times. Its confidence would perfectly match reality. Simple as that. And this isn't just some academic thought experiment, right? In high-stakes fields like medicine or finance, a model that's confidently wrong can be a total disaster. A miscalibrated AI could cause a doctor to miss a critical diagnosis, or a bank to make a terrible investment. Trustworthiness is literally everything. So this brings us to this absolutely massive study that basically set out to find the best way to do this. They didn't just test one or two little things, they staged what you could only call the ultimate bake-off for calibration techniques. So just how big are we talking here? Well, first, they took 21 of the most popular, most powerful machine learning models out there today. I'm talking everything from the classics to the modern heavy hitters, models like CatBoost and Tickle. And then they took those 21 models and pitted them against 5 different well-known calibration methods. This was no small test. This was a full-on battle royale to see what really, really works. The game plan was pretty straightforward, but really, really thorough. Step 1, train all 21 models on a whole bunch of different datasets. Step 2, take their predictions and run them through each of the 5 calibrators. And then step 3, the most important part, measure exactly how much each calibrator helped, or in some cases, how much it actually hurt the model's performance. Okay, before we get to the results of the bake-off, let's just look at the starting line. This chart shows you how all those models performed without any calibration. They're ranked by something called log loss, which is just a fancy way of scoring how good a prediction is. Lower is better. And as you can see, you've got these really powerful models like Tickle and CatBoost already killing it at the top. So the big question is, can calibration make these champions even better? All right, drum roll please, the moment of truth. After running thousands and thousands of tests, the results were in. And let me tell you, they revealed some very clear winners, but also some really surprising losers that kind of challenged what a lot of people thought they knew. Okay, this chart is the whole story, so let's break it down. You've got 5 panels here, one for each calibration method. Now that vertical line in the middle, that's the baseline, meaning no change. The blue bars stretching to the left, that's good news. That's when the calibrator made the model more trustworthy. The red bars going to the right, that's bad. That's when it actually made things worse. And the bigger the bar, the more often that happened. So, who won the bake-off? Well, looking at the average improvement, 2 methods just blew everyone else away. Then Abers came in first with a huge 14.2% improvement. And right on its heels was beta calibration at 13.7%. Plat scaling was a pretty distant third. These 2 are the real heavyweights. But here's the kicker. The real myth-busting moment from this whole study? Some of the most common methods, the ones you read about in textbooks like Plat scaling and especially isotonic regression, can actually make an already strong model worse. If you look back at that chart for isotonic regression, you see a ton of red. The study found it can seriously harm good models. That is a massive warning for anyone working in this field. Okay, so we've got our 2 champions, Venn Abers and beta calibration. How do you pick between them? Well, Venabbers gave the biggest boost on average, and this is key, it was the safest bet. It had the fewest times where it made things way worse. But on the other hand, beta calibration was the most consistent winner. It improved models 67% of the time, so it won the most matchups, you could say. So it's simple then, right? Just pick Venabbers or beta calibration and you're good to go? Well, not so fast. In data science, there's this famous saying, there's no such thing as a free lunch. And that is absolutely true here. These awesome performance gains, they come with some pretty serious hidden costs. And these two charts right here, they tell that story perfectly. On the left, you've got that performance ranking we saw before, with models like Teagle at the top. But look at the chart on the right. That's the ranking for speed, how fast the model makes a prediction. And you'll notice that Teagle, our performance champion, is dead last in speed. The best isn't always the fastest. And using these calibrators adds its own costs to the mix. For one, the study found that all of them nearly doubled the amount of RAM you need during training. But the real difference maker is speed. Our top performer, Venabbers, is a beast. It increases the time it takes to get a prediction by a staggering 140%. But our runner-up, beta calibration, has almost zero impact on speed. That's a huge difference when you're building a real-world product. This summary table just brings it all together perfectly. Venabbers, 3 stars for performance, absolutely top tier, but only 1 star for speed. Ouch. Beta calibration, though? 3 stars for performance and 3 stars for speed. It's an incredible all-rounder. And you can see why something like isotonic regression is still around. Terrible performance, but it's super fast. So what's the bottom line here? It's that there is no silver bullet. There is no one best calibrator for every single situation. What the research makes crystal clear is that Venabbers and beta calibration are without a doubt your strongest starting points. But you have to think about the trade-offs. Do you need that absolute peak performance that Venabbers gives you, even if it's slow? Or is that amazing balance of performance and speed from beta calibration the smarter call for what you're building? Which leaves us with one final and I think really important thought. For years, the number one question in AI has always been how accurate is it? But this research proves that's not enough anymore. The more important question, the one we all have to start asking as AI gets woven into every part of our lives, is this. We know it's accurate, but is it trustworthy?